navigate using the Avenza PDF map.
Everybody, I am honored to be here at WLIA. I graduated from the University of Wisconsin with a geography degree back when computers were the size of rooms and you had to put the input in with punch cards. So it's really great to be back in Wisconsin in some form. So this afternoon, what I'd like to do for you is I've got a presentation that I'd like to run for you for approximately about 26 minutes. And it will encapsulate the concepts and the approaches we've taken through the development process of the U.S. National Grid marker. And you'll hear some of the things that Randy talked about repeated, but there'll be a little different spin with regard to the approach on the use of U.S. National Grid. And to that degree, just be patient as we wander through some of the areas that Randy covered before. But I think between the two of us, hopefully you'll get a mental hook of an idea here that you'll keep the idea about the importance of U.S. National Grid over Latitude and Longitude. So let me fumble here for a minute and try to get everything queued up, and we'll take it away. So hang loose. Okay, so you should be able to see at this point my screen, and you should have queued up and visible there a presentation. So are we good to go? All right, here we go. Well, good afternoon. If you've wandered on by to hear about U.S. National Grid emergency location markers, reducing response times and saving lives at the WLIA annual conference of February 18th, 2001, you are in the right place. I'm Steve Swayze, and I'll be walking you through the story. To start off, I need to frame the discussion by telling you about the nonprofit Shared Geo, where I serve as executive director. 3 key points about this organization, which was founded in 2008 and serves as the public domain guardian of the emergency location marker, or ELM concept. First, we are a geospatial research and development nonprofit. Second, we develop geolocation technologies with the intent of placing them into the public domain so they may be freely used by others. And 3, our project work ranges from the very simple to some which are cutting-edge complex, involving big data and supercomputers. Bottom line, I want to drive home the point: we are a geospatial research and development nonprofit, not an entity which was originally set up to work on a daily basis in the sign or trail development world. Indeed, we came at the issue of standardizing emergency response trail markings from a geospatial perspective of helping the emergency response community. That being said, we became part of that world in 2009 when we were approached by B.J. Kolstead, an emergency manager in Lake County, Minnesota, who brought us the problem statement you see on the screen. She said, "Steve, we're getting calls into the 911 center that go like this: I'm lost between Ely and the Canadian border. Come get me." That request equals a search of about 60 miles of trail in an area where the bugs will kill you in summer and minus 35 to 45 below zero will kill you in winter. Indeed, taken together, the 3 counties which make up the Minnesota Arrowhead are larger than 9 states, and outside of the Duluth metro have a population of about 25,000 people. Getting lost in this wilderness can turn deadly really quick. Related to this kind of situation are accident locations. Accidents have this bad habit of repeating in the same spot, but the injured can't effectively tell you where that location is. Then there is the lack of specificity. I'm hurt at Gooseberry Falls. Gooseberry Falls is a very scenic park in northern Minnesota, but if responders come down the wrong side of the river that leads to Gooseberry Falls,
it will be another 45 minutes before they'll be on the right side of Gooseberry Falls to help you. And as I've already mentioned, the sheer size of the search and rescue areas with limited volunteer assets to respond means anything which can be done to help trail users identify an accident location will go a long way towards speeding a response and potentially saving lives. These circumstances tell us there's an underlying national problem when incidents don't happen at a street address. Data from Delta State University indicates roughly 34% of response calls in the U.S. go to a location without a street address. Recreational trails are a leading category. Trail systems and parks typically employ a marking approach which is locally unique. But locally unique marking systems have no value to responders unless those locations are readily available in dispatch and response system. That involves building and maintaining a GIS layer in every fire, EMS, police, private ambulance company, dispatch, or whatever system that could be out there responding to a call on a trail system. After pondering this situation, ShareGeo decided to come at the situation with 5 design objectives. First, develop a standardized emergency location marker, ELM, which can be used anywhere in the nation in a variety of scenarios. Second, align the marking system with established federal and state cartographic and signage standards. Third, ensure the format leverages GPS instead of requiring constant updating of computer-aided dispatch systems. 4, use a consistent approach which over time will become instantly recognizable by the public. A standard, think stop sign. Everybody sees a stop sign and understands what it means. And involve multiple stakeholders during development to ensure a best practices outcome. Consequently, to develop the signage you'll see shortly, over the course of 3 years we worked with a variety of concerned parties and stakeholders which included Minnesota Geospatial Advisory Council's Emergency Preparedness Committee, Minnesota Department of Transportation, Minnesota Department of Natural Resources, 5 visits to the Lake County, Minnesota Focus Group, which included law, trail riders, search and rescue, fire, tribal, and federal partners. And reviewing our work throughout was a national focus group of responders and geospatial experts. Through this process, we collectively arrived at the belief that the way forward for an emergency location marker system was to use the U.S. National Grid Coordinate Standard. U.S. National Grid, or USNG, is nothing more than the U.S. portion of the Military Grid Reference System, MGRS, a well-established worldwide metric coordinate standard used by NATO and the U.S. Armed Forces since the late 1940s. And its adoption for U.S. emergency response has been steadily growing over the last decade. In November 2011, the 7 federal agencies which comprise the National Search and Rescue Committee designated USNG as the standard for all ground-based search and rescue operations in the U.S. In October 2015, FEMA designated U.S. National Grid as its primary coordinate system and encouraged all other partner organizations to do the same. USNG effectively became the nation's emergency response language of location. As of today, there are now multiple organizations and government entities who have endorsed its use. Here are some of them. One recent notable was the 127,000 members of the Society of Automotive Engineers International, who issued a U.S. National Grid engineering design standard in late 2018. However, regrettably, past experience would suggest few trail users or emergency responders realize U.S. National Grid is already part of their world through at least 2 of the more popular navigation products found in the community. First is the free-to-download USGS US Topo Map series, which in its current and previous form has been published by the U.S. government for over 130 years. If you look carefully, you'll see USNG gridding and location information hiding in plain sight on this nationally standardized product. Same thing with GPS. Pretty much any GPS unit manufactured since about 2008 will have the ability to select USNG or military grid reference system over the default factory setting of latitude longitude. Similarly, with release of the 2019 Federal Radio Navigation Plan, federal money spent on aviation navigation systems must consider the need for a USNG capability in that type of equipment, a SAR helicopter as an example. Speaking of navigation, right about now there's a lot of head scratching with people asking, what's wrong with using latitude-longitude? The bottom line is latitude-longitude was invented for global navigation, not for emergency response in a localized area. Here are some of the issues. First, it's base 60 math, using non-standardized trapezoids, which are not conducive to responders' understanding of local location relationships. This complexity is the reason aviators and sailors spend scores of hours in specialized navigation training programs. Second, it will take up to 13 digits of latitude-longitude to get the same level of specificity you can get with just 8 digits of a U.S. National Grid coordinate. And finally, the worst thing of all about latitude-longitude is there are 3 versions. Confusion about which version was being used to relay information about an incident location has sent responders to the wrong location with deadly results. Effectively, the world is flat when it comes to local location. On the one hand, you can use the base 60 math and the trapezoids of latitude-longitude, or on the other, you can use base 10 math and the uniform-sized squares of the U.S. National Grid. When considered by the collaborative group I previously described, this one was a no-brainer. And that is how U.S. National Grid came to be the coordinate system displayed on the emergency location marker that came out of a developmental process which looked something like this. Which brings us to the end product. The U.S. National Grid Emergency Location Marker, or ELM for short, has the following elements. For the 911 emergency identification, the Star of Life symbol was used to avoid a proprietary issue associated with using the Red Cross. Next comes 2 items which begin narrowing down the location of the ELM. However, because they have value only in extremely rare circumstances, they are displayed using smaller font and set off from the box with 8 digits. First is 15T, the UTM Grid Zone, a notation for an area which is 6 degrees longitude wide by 8 degrees latitude tall, an area that is the size sufficiently large enough to cover almost all of Minnesota and Iowa. Consequently, in reporting a location, it applies only to people who are in Minnesota but actually think they're in Michigan. Second is what is known as the 100-kilometer grid square identifier, in our example denoted by WM. Each UTM grid zone contains approximately 45 squares which are 100 kilometers on each side. The notation WM lets us know which of these 100-kilometer grid squares is being referenced with 8 big digits below. Since a square is 62 by 62 miles, is another large area. In all but very rarest circumstances, we are now down to only needing to report the 8 digits in the white box. Those 8 digits of a USNG coordinate, 2 numbers less than a full phone number, when called into a 911 center, provide 33 feet locational accuracy within an area covering 3,861 square miles. Few call centers cover areas that large, and if responders can't find somebody within 33 feet, well, then there's other big problems. The final design element of the ELM include use of Federal Highway Administration color and font standards, repairability features, and use of an approach which can be maintained in the public domain. Now let's visually pull it all together. On this slide, you'll see the relationships of alphanumerics to area. As I've mentioned in the Minnesota example, 15T covers a very large area. In this example, Victor Kilo represents one of the 45 some 100 kilometer grid squares in 15T, and the 8 digits tell us about a location within that 100 kilometer square. And because you are working with base 10 math, those scary looking digits are nothing more than a percentage of movement from the lower left-hand corner of the Victor Kilo grid square. The first number moves us right or east, approximately 90% of the way across the square, and then the second number moves us up or north, about 60% of the way in the square. Basically, all you have to remember is read right, then up, just like in grade school when working with X and Y axes in units. 9 units right, 6 units up. So, by what I know about basic Minnesota and Wisconsin geography, and with nothing more than a simple graphic, I just figured out a response is needed on the east side of the Twin Cities suburbs, a process which, when repeated on an appropriately scaled and visually detailed map, will show a location with 10 meter or 33 feet accuracy. When we finally released our first ELMs in 2012, we offered 3 sizes to our pilot partners. 12 by 12, the size the Minnesota DNR endorsed for use at trailheads and warming huts. 9 by 12, the Minnesota Department of Transportation standard for motorized trails used by snowmobiles, ATVs, and similar, and 6 by 9 as recommended by our focus groups for use on hiking, cross-country skiing, jogging, and other human-powered type trails. Driven by a reduction in trail response times that have been reported as high as 90%, this first project in northern Minnesota has now become multi-state deployments and inquiries. 2 of the more interesting are: in 2018, a select panel working for NASA's chief technologist, the Science Office of NASA, selected ELMs for installation on Kennedy Space Center. That system is now supporting over 1 million visitors per year at this nationally unique site. Similarly, in 2020, headquarters of the National Park Service authorized installation of ELMs on Kennesaw Mountain National Battlefield Park, a park which sees over 2.5 million visitors each year. In addition to the expanding number of locations where you will find ELMs, we've also worked with our trail partners to continue developing different versions which support different use scenarios. There is now a vertical breakaway version, a 3x5 sticker which can be used to retrofit fiberglass posts, and customized versions to support specific local needs. To support awareness, we have also developed a standardized information sign which is available either in metal for posting or polyvinyl to support responder training events. Another issue that has been addressed is the creation of the informational kiosk. In this case, the product has been engineered so that it can be attached to a wooden backboard or attached to post with pre-drilled holes, U-channel or other. It is also printed on both sides, so there is the opportunity to rotate to a new sign if only one side had previously been visible. In response to requests for supporting items, we have developed trail access point signage for responders and unique items like call box informational placards. Finally, as I indicated when we began, we are a geospatial research and development nonprofit, so we have also been adding to the technologies available to support USNG implementation in general, and ELMS specifically. Here are two examples. First, usngapp.org. Simply entering that URL in any mobile platform instantly displays your USNG location in the format of an ELM. And once loaded in your browser, it no longer needs an internet connection. We are aware of at least one significant rescue which has been facilitated by this technology. Second, for those who would like to print an ELM on demand, we've created a point-and-click print map interface which also has a derivative which will allow mountain bike racers or whoever to go into the field and print race course markers on demand on site. As I approach the end of this presentation, the question I get most often is, okay, this is all well and good, but it looks way too complicated, and how would I ever undertake a project like this? Basically, there are 8 steps which any determined individual should be able to make happen. First step is the most important, and regrettably, there isn't much point in proceeding past step 1 if you can't make it happen. With ELMS, you are installing a community product, not just something for your trail system. So you need to build a team that believes in the collaborative process and understands effort up front will ultimately benefit the community by reducing response times and making the public feel the trail is safe. So you'll need all these stakeholders at the table, all willing to recognize trail response could be handled better than it has been. Then it's, here's this idea, what do you think? If you can come out of that first step with a green light to continue planning, your next step is to create a rough plan for your trail system so you can get a handle on potential cost. To that end, here are some of the basic planning factors which you can use to create a rough estimate of what it will cost to place ELMS on your trail. If you are planning a rural trail system, anticipate you'll need 1 ELM per mile to meet location needs I'll explain in a minute. Whereas on an urban trail system, ELMS average about 1 every quarter mile. Budgeting factors for delivered, tax-paid items are currently approximately $30 for an ELM, $35 for an info sign, and $55 for a vertical ELM. We expect those costs to come down over time as we gain efficiency in production, planning, and management. Hardware has historically run roughly 10% of the total cost of the signage in the project. Depending on how your team is approaching your ELM project, the next 3 steps can be happening simultaneously or pretty much in any sequence. First, you'll need funding. There are a variety of places to look for funding. To name a few, federal and state trail safety improvement programs, corporate safety grants, trail user fundraisers, local government funding, and even sweat equity. Labor donated by scouts, trail riders, hunting organizations, etc. Next, you'll need to accurately record the location for your ELMS. Although each community is different, those locations have typically been trailheads, road crossings, known accident locations, trail junctions, camping areas or rest stops, and set distance if you're working with an urban trail system. Last, you'll need to order your ELMS, info signs, and hardware. Beforehand, you'll need to work through lots of issues with your team, some of which include contract, purchase order, credit. How should we do this? elm sizes, mix and type, custom products. Where are the supporting artwork and logos that we'll need for our elms? Engineer or high intensity prismatic laminate, 3M or Avery laminate, type of posts, what hardware will be needed. Is our elm location spreadsheet ready to go in the format requested by the manufacturer? Obviously, many of these questions will have been worked out in advance during talks with ShareGeo if a self-installed project, or with a certified elm installer if the job has been contracted out. But at this point in the project lifecycle, a final review is in order given the unique nature of this approach. At step 6, there are two basic needs. For first responders, train, train, train. Because once elms go up, the first call could come moments later, and for call centers, depending on CAD configuration, ensure both the operators and equipment are ready to go. Step 7 is straightforward. Install elms and keep practicing. Finally, at step 8, you'll need to publicize your efforts to ensure the public knows how to use the elm system. Examples of past efforts include YouTube videos, stories on local television stations, informational brochures for public outreach, and blogs, as was done at Kennedy Space Center. Then there are story maps, hands-on displays at safety training centers, and even festivals. Well, this all looks like a lot of work, and would we really get any kind of return on investment out of all this effort? Consider the cost of a SAR helo if someone is lost on your trail system, and it comes down to needing to use infrared to find them. The tab is going to run at the rate of $5,000 to $8,000 an hour. Then there is the question of what is a life worth. In May 2013, school children from an outlying suburb of the Twin Cities were on a field trip to Lilydale Regional Park, which is situated in the very metro setting of St. Paul, Minnesota. 2 children from that group got buried in a landslide, and it took responders nearly 50 minutes, as in 50 minutes, to get to the site because no one could adequately describe where the incident had taken place. So after the tragic deaths of these 2 children and a payout of $1.5 million in claims and engineering studies, what was one of the steps the city took to correct the situation so it was protected from another tragedy of this nature? They spent $736 to install elms in this park. I believe the return on investment with this one is pretty obvious. As I said in the beginning, ShareGeo never intended to get in the sign business, but here we are. To that end, we are currently in the process of substantially upgrading our online store with ELM system planning information, ELM stories in the press, videos, and similar. If you are interested in learning more about the ELM system, stop by and check it out. Thank you. That concludes this presentation. Please feel free to contact me at the email shown on the screen if you have questions or you would like to discuss an ELM project in your community. Thank you very much.
Okay, thanks for hanging with me on that. I am going to jump back to my main screen and open the floor here if there's anybody that's got questions that they would like to ask. Okay.
Thank you. I put your email and the website in the chat from your last slide. If
Okay.
anyone is too shy, they have your contact info.
Sounds
Well,
like
I have a question. Could you talk a little bit more about the mobile app and how that works? I mean, I think that might be one of the biggest hooks.
Yeah, so let me try to jump back to where I need to be here. The mobile app One thing I do want to share, if you would write down this web address, sharedgeobooth.org. We've put for this event up on that website a large number of items that are that support the presentations that have gone on, both Randy's discussion, information provided about that app. So you can just pop over there. In fact, there's even, I discovered this afternoon actually, a installation guide I wrote ahead of doing a presentation for the Illinois GIS Association, and you can find that there. But circling right back to your app question, there's a flyer there that describes how you manage to turn that on and what you can get out of it. So there you go.
So this is not something that's currently out on like the App Store on Apple or
Yeah. So if you understand, yeah, it exists. I believe it is still up on Google. Randy, jump in and help me out here.
Well, there are three options there. The usngapp.org is a website URL, but what it does is it installs, I believe it's JavaScript, right, Steve? But it puts it into manifest memory on your smartphone, so that you don't need an internet connection once you hit it, which is pretty important. It's a real simple application. And so when you go back to that URL, it's going to show your location in that format. Now the USNG app is an app, it's in the App Store. So there are multiple options, I guess. It's nice to be able to show your location in that ELM format without having an internet connection. You know, you don't need internet to use GPS, right? So, you know, you want to preload that before you go out on the trails, you know, but there have been instances where, you know, I've talked to first responders that have actually instructed people to go to, if they've got their smartphone, go to usngapp.org and tell me what it says. And from there, they're able to figure out where they are. So I'm not, did you have a specific question about the app? I mean, what are you looking for?
Well, I quite honestly, I'm with Dane County, and so I've had numerous conversations with different groups, whether it be a mountain biking group or somebody on the Ice Age Trail or various fire departments, and looking for, you know, basically trail referencing systems, and everybody comes up with these unique, locally developed systems, and I've been monitoring Elm for a number of years. More recently, I know some people are very involved with the Lower Wisconsin Riverway, and they're starting to talk about some kind of a referencing system that they can place on the landings, and other locations, and then also how to share information with people who use the river, and how they can provide, you know, coordinate information, because once you get on parts of the Wisconsin River, you might not even have cell service. So I've kind of been talking with them a little bit about Elm, and this has been a great presentation, and I'd like to start to try to get some of my county departments and maybe some of the other municipalities that have trails throughout the county and going into neighboring ones to start using some kind of a unified system.
Well, I have two comments. One is, you know, everybody creates their own system, so it's not universal. This is part of a national standard. That's important. The other is that those numbers relate directly to GPS coordinates. So, you know, you come up with some, you know, a mile marker, which is a linear referencing system, or you come up with an intersection numbering system or something like that. It only works within the context of whatever that is. Like in our parks, for example, you know, they came up with a logical numbering system for all the trail intersections. You can create a map that shows where those trail intersections are and puts the numbers on them and things like that. But when you start talking about it in a larger context, okay, well, how does that, so you got you're going to repeat the numbers when you go from one park to the next park and things like that. Now here you have a unique identifier for each of those locations. One thing that we didn't mention, because this actually works well, and some are using it for asset tracking. So it's a very easy way to create unique identifiers for fire hydrants and light poles and park benches and whatever. And it's all based on GPS.
Right.
So it applies in a lot of different ways, not just emergencies.
I guess one other follow-up question, and just looking at some of the chat, in the slide presentation, Stephen, that you had, that it showed Wisconsin has had, I think it said 6 projects or something are underway. Can you speak to some of that? Because I see some statewide efforts, like the Ice Age Trail, that this would be an exact fit for.
Right. Yeah. So just as a background, back in 2015, I believe it was, I spoke to the Wisconsin Trails Council, and they, in fact, on the backside of that, Brian Much and the group there, they endorsed it. And to the degree that it's been implemented in any way in Wisconsin through that linkage, I'm not aware of it. Brian, we recently chatted about it. Right now, there's a collection of counties in northern Wisconsin, Bayfield, which, of course, you've got Carmen, who's been deeply involved in this event. I believe it's Sawyer County, and Randy in the past has had several discussions with folks over in Oneida, Vilas, and Oneida. So I think it'd be really super cool if eventually there are some implementations up in the UP of using US National Grid for marking their trail system. We eventually could get to the point where, again, because it is a universe, the design standard was to be universal. It allows you to cross the number of boundaries, state and county. So that'd be a wonderful thing. Fred, if I could, I'd like to jump over to a question we get very often that Gail put up. And that was the question about the issue of what about what 3 words, and why don't we do that? First thing I'm going to tell you is, first of all, you're ignoring the fact that what you're trying to do is implement something that is a proprietary product of a corporation to override a federal standard identified for emergency search and rescue, and to be used. FEMA is the gold standard, if you will, of what you're supposed to be using within the NIMS and ICS system. And they're saying, we want you on US National Grid. So what 3 words is great as a, if you will, entertainment piece and a way to connect people on a local level. But in terms of responding in the emergency response world, it's a bad way to go. And what 3 words is only one of many, and I've got them listed up there. And you can find this over on the page for the USNG store under frequently asked questions. And we've walked through everything about, well, can't they determine my cell phone location? And, what's the downside of creating locally numbered trails, and so on and so on and so on. And so you'll find the explanation there for what 3 words, Gail. So take it away. And this is laying down the gauntlet. Jack, anytime you want to debate the issue of what 3 words against US National Grid, I'll be more than happy to do it. There.
All right, thanks, Stephen. We don't have any more time for questions. We're going to go ahead and jump into our sponsorship slides. Thank you again, Stephen and Randy.
Thank you very much for your attention. Greatly appreciate it.